guys, welcome back to Bihar Geek. So today we are going to solve a very interesting problem, that is copy list with random pointer. Okay, so this problem is common coding challenge that requires you to basically clone a linked list where we each node has the next pointer. Okay, and additionally here we will also have a random pointer which may point to any node or of the list, or maybe to the null also. As you see that like seven random is like pointing to the null, and some other, like if you see the 11th one, it's pointing to the another node. Okay, so the problem statement here says that basically we have given a list. Okay, and the statement is too big, uh, so basically here we have a int value which represent the value of the node. Okay, as you see, like 3 is there. Next is the next pointer, okay, which is pointing to the next node of the list. Okay, this is the next. And third is the random that basically point to any node of the list, or maybe to the null also. Okay, which we already see. So our task is to create a deep copy of the list. Okay, so I'm going to use two approaches here. First, I will start with the hash map, where the time complexity, if we talk about, it will took around of n. Okay, and same for the space also. So let's start coding. Okay, so the approach is like a way that we will use a hash map to store the mapping of the original nodes of their clone counterparts. Okay, and then we will create a new node for copy the list and store them in the map. Okay, and at the end we will assign the next and random pointer by referring to the hash map. Okay, let me show you by the code how we are going to achieve this. Okay, so first we need to put a base case here, that what if the head is equal to null. So in that case we just simply return the null. Okay, next we have to which I already told, the map, basically we need a hash map here. Okay, so this hash map basically to store the old node as a key, and new nodes as a value. So it will be of type node here. Okay, and secondly we'll have new nodes also. Okay, and we'll keep a name as a map equal to new hash map. Okay, this is done now. After that, now we have to start with the step one is to clone basically node without assigning a next and random pointers. So I will keep the name as current and keep the value inside it, the head. Okay, now we need a loop to iterate. Okay, so current will till not equal to null till the loop will run, and where map dot put, we will put the current comma the new node. The new node will be the current value which it have, current dot val inside it. Fine, this is done. Now we have to increment the pointer. Okay, so current is equal to current dot next. Fine, this is done. Now we have to move to the step 2. Step 2 is to assign next and random pointer using the map. Okay, so again we'll keep the pointer reset. Now we'll keep the loop again, where current is not equal to null. Okay, and we need a clone here. So we'll make a clone clone node equal to map dot get from the current value. Correct. Fine. Now let me now copy this. So clone node dot next will be equal to map dot get, and inside that current dot next, right? Basically we assign to the next. Now we have to assign the random now, so we'll keep dot random will be equal to map dot get current dot random. Okay, and we assign the random part. Now we have to increment the pointer. Current equal to current dot next. This is done now. Mm, fine. Now, now we have done with that. Now we just simply need to return map dot get and the new head. Okay, this is done. Okay, notice and node type, and we are getting the head only. Okay, so let me run this. What is happen? Map dot. Okay, one more R is left. Right here. Okay, let me run. Okay, it's got accepted. Let me submit this. Okay, it's got submitted also. So this is the approach one, that is we use with the hash map, where we basically what we did use a hash map to store the mapping of the original nodes. Okay, here which we have did, and then after that we have basically create a new nodes to copy the list from the store them basically in the map which we did here. Okay, and after that we have like do the assignment of the random and the the next pointer which are referring. Okay, which we have done, and finally we have returned the result. So this is approach of hash map. Okay, and whether if we talk about the space and the time complexity, so both are O of n only. Okay, now let's move to the second approach. Okay, so it's like optimize in place. Okay, and if we talk about the complexities in this case, so the time complexity is same as which we have used for the hash map case, but the space complexity in this case will be O of one only, the constant. Okay, so the approach will be like, let me now first clean this. And this case is already needed, so let me clean this part. Okay. So the approach of this optimize in place will be that we will create a duplicate node. Okay, and then we will insert them to the original node, and then we will assign the random pointers to the clone node. Okay, and then we will separate it from the original list. Simple. Okay, so first we have a same that base condition will be there. Now we'll move to the fourth step which we talk. The fourth step will be that we have to create a clone node. Okay, and we need to insert them into the original node. So we'll keep the name as current, and the value will be assigned head. Okay, now we need a while loop here, and while loop will have current not equal to null. Till that the condition is true, it will be iterate. Now inside this we need a clone. Okay, that will equal to new node. This is step is exactly same where we are using the hash thing. Now here we are directly doing inside a node only. Value. Okay, fine. Now clone dot next will be equal to current dot next. Okay, it's exactly same. Now we have to do the iteration dot next will be equal to clone one. Okay, now the current will be equal to clone clone dot next. This is done now. This is first step where we have basically clone the node and insert them basically between the original nodes. This is the first one. Now we have to do the assignment of the random pointer to the clone node. So again we have to reset the head. This is done. Now we need a loop here. Again for the over the current. Current not equal to null, and here we have to put a condition also that maybe that current is null, while means that maybe the current random is maybe equal to null. Okay, so in that case we will do the current dot next dot random. If it's not equal to null, in that case we will put current dot random dot next inside this. Current and current random next. Okay, fine. This is fine. Now we have to iterate. Sorry, iterate, not iterate. We have to increment. Dot dot next. Fine. Now the last step will be we have to separate the original and the clone list. So again we have to reset the head. Fine. Now we need a node and we'll keep the name as like clone head. Okay, and that head will be, and this head next will be there. Okay, and again we need a one more thing, that is clone, and we'll keep name as, and we will assign that clone, mhm, clone head. Okay, after that we need another loop. Okay, because we have to separate it from the original list. So current not equal to null. In that case, hmm, it will be exactly like this only. So that current dot next will be there, and we have to put do the increment dot next and next. After that, we have to check that maybe it's not equal to null. In that case, we have to first write this now. Clone dot next equal to null. Not equal to null. In that case, clone dot next is equal to same which we have done for the current. Next dot next. Fine. After doing this, we have to move the pointer. Dot next and clone is equal to clone dot next. Fine. Now we will have a actual final result which we have to return. Okay. So clone and we have kept the name. Okay. So this is done now. Let me this spelling is mistake. And let me run this. It's got accepted. Let me submit this. Okay, it's got submitted also. So we have used the two approaches here. Okay. So first was the hash map where the time complexity was O of n, and same the space complexity was O of n, and it was like easy to implement. You have seen that there is not much loop where we have first did with the value actual values, and after that we have put it the next and the random after that. So there was thing is that we need a extra space only, and in this case the in place where the time complexity was same like O of n only, and the space complexity was O of 1 only, but it's more optimized than that, but little complex, like you have seen that there are multiple loops are there. Okay, So it's like little tricky, like slightly tricky to understand, okay, in this case, but it's like the space is optimized in this case. So that's all for today. Thank you for watching. Bye bye.